Starting at the stream. I got like 2.5 minutes. I could do this. I can do this. Adventofcode.com. 2 minutes and 30 seconds. Okay, let me do a quick AV check. Test. 1, 2. Okay, let me do a quick AV check. Test. 2. Cool. Cool. And I have the quality options today. That's good. That's good. We're all good. All right. Nothing like starting last minute. At least I'm not late. Oh, I need to do the Discord thing. I got a minute and a half to do this. So, stream plan. I am almost late, but starting on time for day 16. Twitch.tv Raimu. Okay. Disabled emote only. The stream title's correct. It's day 16 of Advent of Code 2021. Advent of Code? It's an advent calendar of programming puzzles. You can do them in any language. It's been going on for about 6 years. I started in 2019, did all of 2020. I gave up on 2019 around day 20 or so. Trying to do all of 2021. I've been doing 2016 when I just need to warm up or something. And they're Christmas themed. The themes are pretty corny. So the theme this year is that we dropped the keys to Santa's sleigh into the ocean, and we got to get into our submarine and chase it down, and we're going through all these adventures. Each day there's a little Christmas themed corny story that kind of frames the programming puzzle we're supposed to solve. But basically they give us some text input and we have to run a program to generate the output, and there are rules that they give us. Usually they're related to some well-known algorithms or other exercises. So yesterday was a path finding challenge, so we solved it with Dijkstra's algorithm. Other people have solved it with breadth first or gone further and done A-star algorithm or done their own thing. A lot of time you can get away with brute force. And I totally don't have the framework ready for day 16, so that's going to cost me about a minute, but that's okay. We're going to do this. Hey there, Marco Dev. How are you doing? You ready for day 16? Anybody else doing it along with me? Good luck. May the fastest win some points, maybe. All right, here we go. Packet decoder. As you leave the cave and reach open waters, you receive a transmission from the elves back on the ship. The transmission was sent using the Buoyancy Interchange Transmission System, a method of packing numeric expressions into a binary sequence. Your submarine's computer saved the transmission in hexadecimal, your puzzle input. The first step of decoding a message is to convert the hexadecimal representation into binary. Each character of hexadecimal corresponds to 4 bits of binary data. The bits transmission contains a single packet at its outermost layer, which itself contains many other packets. The hexadecimal representation of this packet might encode a few extra zeros at the end. These are not part of the transmission and should be ignored. Every packet begins with a standard header. The first 3 bits encode the packet version, then the next 3 are the type ID. These 2 values are numbers. All numbers are encoded in any packet are represented as binary. The most significant bit first. For example, a version encoded as a binary sequence 100 is a 4. Packets of type 4 represent a literal value. So we're doing TCP/IP. How ironic. Literal value packets encode a single binary number. To do this, the binary number is padded with leading zeros until its length is a multiple of 4 bits, and then it is broken into groups of 4 bits. Each group is prefixed by a 1 bit, except for the last group, which is prefixed by a 0 bit. These groups are 5 bits. Immediately follow the packet header. For example, the hexadecimal string D2FE28 becomes, there's the packet ID and version. Is that right about that? Yeah, version and ID. And it's version 6, type 4. And there's one group, which is a, that's not a D. Let's see, how did I do this wrong? First 4 groups of the number. So why is it a D? How did they get a D out of that? Wait a minute. So this... Oh, that's this as hexadecimal. Got it. All right. So then, yeah, it's 0111, and then 1110, and then the last is 0101, and then pad it with zeros. Right. Okay. I know how to read that. So it's the literal that, which is 2021 in decimal. Every other type of packet represent an operator that performs the calc. Oh no, it's int code again. Hey there, Aneurysm. How are you doing? On one or more subpackets. Right now, the specific operations aren't important. Focus on parsing the hierarchy of subpackets. An operator packet contains one or more packets. When they say aren't important right now, that means part 2 or tomorrow. You like this puzzle? Yeah, I'm already liking it. An operator packet contains one or more packets to indicate which subsequent binary data represents the subpackets. An operator packet can use one of 2 modes indicated by the bit immediately after the packet. It's called the type length ID. The type length is 0. The next 15 bits are a number that represents the total number of bits of the subpackets. If it's 1, the next 11 bits are a number that represents the number of subpackets immediately contained by this packet. Interesting. So it's either length prefixed or it's just a number of packets. Wait a minute, what does it mean immediately contained by? Okay, I guess I'll explain it first. Finally, after the length ID and the 15 or 11-bit field, the subpackets appear. For example, here's the operator packet. Blah. So it's a 0. So that's the length. So 27 bits. Yeah. So these are the 27 bits. The first 11 identifies it as a literal 10, and then a literal 20. And then the how do you operate on it? Is it? They'll explain it. Hold on, where do they explain it? Just perform some calculation. Right now, the specifics aren't important, so we just need to get we just need to parse it. We're writing a parser. So they give me another example, and then another. Okay, this probably example uses the. That's the first one. So the second one uses the 1, right? So how does that work? So 11 is the number of subpackets. Okay, so then you just keep reading until you have read that many subpackets. Got it. Okay. The number of subpackets indicated in parsing of this packet stops. Right now, parse the hierarchy of packets throughout the transmission and add up all of the version numbers. Here are some more examples. Version 4, version 3, version sum of 23. What's this? Oh, I see. So they give us a bunch of examples with different sums. So we can make like, okay, here's where I'm a little bit behind because I haven't set up my day 16 sandbox, so to speak. Let's try to set that up really quick. Really quick, time's wasting. Delete. All right. This is to do. And that's to do. Okay. Oh, not done yet. In lib, I need to have a mod day 16. And then down at the bottom. Not at the bottom. Near 15. Just so I don't get confused. That's a 16. Okay, and then we don't have a 16 doc text. Now we do. Main, I'm going to need this. Might as well put it in now. Mistyping. I need a new keyboard. I make so many typing mistakes. I need a new keyboard. I might be getting a new keyboard. Right before the stream, I was looking into that. Okay. Hey there, Adam. How are you doing? Fancy you showing up right now. Backed your way into the mainframe. Okay, we're decoding packets today, looks like. So let's pick out their examples where they say like a 16 is what we get from this input. We'll just break this up, right? And then this one is 12. And if you're responsible for me not being prepared, no, that's okay. I really didn't need that much time to prepare. What did that take me to set up the shell for this? Maybe a minute. And what's a minute more or less when it's going to probably take me half an hour and I'll already lose? I'm not in the running for speed coding it. So yeah, I was looking into if you're in Adam's Discord, I was looking into the different keyboards that we're nerding out on, and might be getting one of those, because I think what it's come down to is the keyboard I have has too many keys. All right, so if I run this test now, I think what helped me transition to the barking dog right next to me. Transition to the idea of getting a keyboard that's different is the one I have is a Kinesis, and it has 2 layers, and I didn't realize the power of having a multi-layered keyboard until using this one. But like, I need to go to the next level. All right, so let's get the input because it's multi-line, right? Is that just one giant line? Hold on, they give me just one line? Okay. So they gave me one huge, like... Oh, it's a sequence. They're all sequences. So then, let's verify. Yeah, it's one huge line. One huge line. Yeah, I'm thinking about my parameters are a keyboard where I don't need to move my hand, or I don't need to reach my fingers over, except for up and down one. Up and down one's fine, but like up 2 is hard. I have a hard time doing numbers, and I have a really hard time hitting the bracket keys. And backslash. Backslash is the worst. I almost have to, like, I'm doing it now. I have to look down on my keyboard to see where is that backslash, where is backspace. I hate it. And I can overcome some of that with the keyboard layering, but I'm like, why don't I just like try to make the next step? Okay, so I think the first thing I want to do is turn that into a string of bits, and those bits are going to feed into, like, are going to go into a queue that we can pull any number of bits out that we need. So something simple. We want to know the number, so why don't I just make it where we just do a shifting, and the easiest way for me to just transform it just into a vec queue of bits, right? So let mutable bits equal, well, actually, why don't I just make a structure for this? That'll make it so much easier down the road. Transmission. And in here we'll have the bits as a vec dequeue of bools. And vec dequeue needs to be imported. Use 75% keychron? What's that? Be using a Redux. So I'm thinking about the Korn MX with replaceable switches, so that if I change my mind about the switches, I can change that. And I'm thinking about getting, like, leveraging the power of LED light to help train my brain to be more efficient and make less errors on the layer, especially with multiple layers. Okay, so this is a what's a shorter thing? How about we just call it packets? No, it's not it's the input. Let's just change the input. Let mute input equal transmission, where the bits is, can I collect into a vec dequeue? That's a good question. Input.chars dot split, no, not split. No, before I do chars, I want to trim it, because there might be an extra new line at the end. Chars dot map C into Actually, let me turn this around. Let me just say transmission default. Implement default here. A Redux and a Moonlander. The keyboard bug bites deep indeed. I looked at the Moonlander, but the Moonlander has too many keys, so that doesn't really appeal to me. If one of my search goals is a small number of keys. It looked to me, the Moonlander looked to me just like almost the same thing what I have, but with thumb buttons. And I'm like, it's not too much different from what I have. I could be wrong though. Maybe I have a wrong impression of it. One for work, one for play. Don't you get really confused though? You train yourself on one keyboard and the other one's different. Okay, so the idea here is instead of trying to assemble it in place, I'm going to say for C in this. And I'm going to have a method of the input to say push C. Let's see what that gives me. So impl transmission. Where we have a function input mutable self, and then digit is a char. And then call it input, not input. And then it's always going to be uppercase letter or 0 to 9. So let's do a match. This is the easiest. I'll just do all 16 combinations here. Match digit. Underscore will be panic. I turned the ligatures off for now because it was confusing people that were watching. Let's see. Call it bad input. Okay. Enough fun. Alright, so then what I want out of this is 4 bits. Let's just keep it really simple. 2, 3, 4, 5, 6, 7, 8, 9. And I'm sure there's a add-on to VS Code that will just type these numbers for me, but I am too lazy to be concerned about that. So 1, 1, 1, 1, 1, 1. Also, this helps teach people binaries, so I have an ulterior motive. 7, 8, 9. And then we continue into A, B, C, D, E, F. Plus, this will be ripping fast, right? Because this will map directly to something that we're going to then push into the vectq directly. So that's that. If I did it right, this bit alternates every time. This one alternates every other time. This is every 4th, and that's every 8th. Okay, now what do we do with that? We're going to say for bit in that dot into in iterator self dot bits dot pushback bit. Oh, I need to turn all these zeros into falses. Whoa, how'd he do that? Magic. And all the ones into trues. Cool. So then we get our bits. What's wrong with this one, though? Probably I don't have the end of it done yet. Okay. See, Adam's busily typing with his 36-key keyboard the text for the next YouTube video title, where he takes a clip of me and then transposes it. That was awesome, by the way, Adam. I loved it. When did I ditch the numbers in my name? I ditched them when I could. For the longest time, I would try to rename it and say that name's taken, and I'd be like, sad face. Finally, one day it said, are you sure you want to change it? You could have to wait a month after. And I'm like, I'm not going to wait a month after I change it. This is permanent, baby. So it finally became available, so I got the name back. Okay, what's wrong with trim? Inputs a string. What am I doing wrong here? Oh, that because I have this wrong. This is shadowed. Call it something else. I give up. I'll call it transmission, even though it's a long word. Okay, so the idea is we did I not call it push? I didn't. We push a character into the transmission, and that puts bits in to the back, and then most significant bit first, and that's important because when we pull them out, we're going to pull them out most significant bit first, right? So let's make sure I did it correctly. So let version equal transmission dot pull 3. Now, what does pull, you say? I'm glad you asked. Pull is also going to mutate self and then have a count, which is usize, and it's going to yield a number. See all these mistakes. All these mistakes. We'll fix this someday. So I'm just going to shift it in, right? So let mute number equal 0, and then for don't care loop variable in 0 to count, we're going to say number shift left 1, and then at the end we're just going to say number, and then here it's going to say if self dot bits dot pop back front dot unwrap number plus equal 1. Basically, we take the bit vec dequeue, pop the bit off the front. Unwrap is because if it's empty, we want it to crash at that point, and then that becomes a true or false. If it's true, it's a 1, so I want to add a 1. So then let's see what it is. We will debug this, and I'm just going to run it just to make sure. There's a sanity check. We should get what should we get for that example? Version 4, right? We should get a 4, and then it should crash, or it should finish soon after. 4. So I'm right. First try. Self-promotion tax? If you're interested in learning more. Yeah, you should watch Adam's video on his journey making his own keyboard. That helped me out a lot. Did they do away with that kind of cheering? How do you cheer? Oh, you can't cheer in my channel because I'm not a Twitch affiliate anymore. I gave that up because I wasn't allowed to stream for a while. I could probably get the affiliate status back, but I didn't want people to be cheering and subbing to me when I wasn't allowed to stream. I just didn't feel right. All right, anyway, let's move on. After we get the version, is that all we need to do? Oh, no, we need to look at all the versions. So we need to continue, right? In fact, we need to repeat until it's exhausted. So let's actually put this in like a while, not transmission done. And then done can be another function that we have where we just borrow self, return a Boolean, and we're done when self.bits.is empty. Power of functions. All right, and then we're going to want to have a version sum. And ultimately, we're taking that version sum and putting it to a string and returning that, right? And then version sum here plus equal version. But to get to the next packet, we got to read the next bits, right? The type ID. Let type ID equal transmission, not pull 3 more bits out. And then depending on the ID. So it told us about 2 different IDs, right? 3 and 4? Oh, every other packet. So really it's if type ID equals 4, else it's something else, right? Oops. Again, keyboard mistake. Are we counting keyboard mistakes? I should have like a keyboard mistake counter that shows in the corner of my stream. They do, that's why I can't do. Yeah, I know. Sorry, Adam. Yeah, if I... another thing is if I, what am I trying to say? If I registered to be affiliate again, I think I'd change the tax stuff anyway because I would do it personally and not under my LLC anymore because it's not for that business venture anymore. So it makes sense that I'd have to change the stuff around anyway. You stuff some random gems into an envelope, mail them to me. Make sure they have a Mr. Destructoid logo on them. I'm gonna get like this weird bulky envelope next month, and it's gonna be like 100 Mr. Destructoid pencil eraser ends, and I'll know it came from Adam. Type 84. What do we do with that? It's a literal value, and if it's a literal value, we hold on. I probably read this too fast. Okay, yeah, we read groups of 4 and look at the first bit. Okay, so it's while... Am I right or you're right? No, we have to read one bit. So while transmission.poll 1 bit equals 1. Actually, we want this turned around, actually, right? We want to do a loop. And this is going to be let more equal. And then let mute literal shift left 4 literal plus equal transmission dot pull 4 more bits, right? And then if not more break. That's 4. We're not doing anything with the literal. I guess we can print it out. Help us debug. Literal. Okay, for every other type, it said that there's a length type ID. So this is really called a packet type ID. And then we'll have a length type ID equal transmission poll 1. If it equals 1, let's just do E0 or 1. Actually, the purist in Rust would probably tell me to do a match. There are only 2 possible values. So you can say 0, do something, 1, do something else, everything else is unreachable. Right? That's what a Rust purist would probably tell me to do. And I kind of like the elegance of that. What's 0 again? Next 15 bits are a number. It's the total length. So let length equal transmission pull 15 bits. And then those are sub packets. So then I'm going to want to make a recursive call, which means this whole thing needs to be in a function. So why don't I pause for a moment to put this into a function called parse packet, I guess. Poll. Let's call this one poll. I can't rename it. I'm in the middle of moving something. Hold on. That's going to be poll bit. We'll call this one poll packet. Self, and we'll have like a limit. This is an optional number of usize, and that's going to return nothing for now. Actually, what we want to return is the version sum for now, but we're probably going to want to return more than that later. Okay, so transmission becomes self. Version sum, we need to actually that is, we will have to track that. So let mute. Why don't I just do it this way? Make that equal. I don't even need that actually. No, yeah, do I?
It's too easy.
I think I will. I'm thinking ahead about whether I'm going to mutate that variable or not. Actually, I can combine these two. I don't feel like that. I feel like even though we only use version here, I feel like we're going to use it other places later. Anyway, At the end here, we want to get version sum out. And
Swapping those.
we don't use it yet. But okay, down here though, it's going to be version sum plus equal transmission poll packet none. Like that. Right? So in here, I'll pull a packet and give it a length. So, total number of bits. So it's while. Oh, I'll need to know how many bits came out too. Shoot. So what if I just invent a type called packet and I'll put like version and total bits in there for now. So struct packet version use size and length use size. There we go. So then this becomes packet version. It's version sum. Version sum, and then we need to keep track of the number of bits. So I know what I'll do. I'll just have a let starting bits equals self dot
You can't hold that one down.
bits dot length, and then when we get down to the end, it's length is self is starting bits minus self dot bits dot length. There we go. Okay, and then down here it's a little bit different. I need to get like the packet. Hold on. I'm in a rush because I'm trying to get a good time, and so I might be missing some chat. How's the bit parsing? It's going really well. I'm having fun. Bits parsed, though maybe not made sensible. I think it's sensible. Sure is a lot of iron oxide in here. Sure is. I have a knack of making even Rust comprehensible. You mean incomprehensible? Let packet equal that. Version is packet plus version sum. All right, back to poll packet. So here when we have length, it's going to be while. I guess we'll just make this mutable because it's while length is greater than 0, right? Let sub packet equal self dot poll packet. The limit is some length, right? And then version sum plus equals sub packet version sum. That's all I need to do. Oh no, I need to say length minus equal sub packet dot length. All right, so that's type 1. What's type 0? What's type 1? Next 11 bits is the number. That's easy. Let num packet sub packets equal self poll 11. For something in 0 to num sub packets, same thing, right? Only we don't need the length. And there's no limit to the number of bits in the sub packet. I think I'm done. We're going to go for it? Let's go for it. Run those tests. Yeah, 2 panics because we haven't written yet. Failed. Okay, I think I just need to run part 1 on its own. So versions 4156, is that right? At least? Go down. 4156. Oh, we tried to pull again. That's bad. And that's why it panicked, because there was a none on line 27. Yeah, we panic on line 27 here if we run out of bits. So why did we run out of bits? Maybe my while loop down here is wrong. Where am I? Is this done? Bits is empty. It's true if it's done, while not done. I need to dump out more. I have something wrong here. So let's print out something here. Let's put a debug here. And a debug here. see what I did wrong. I haven't had to do with a debugger in Rust in a very, very long time. Usually I get away with just debug printing at various points. Cheering is turned off. Exactly. That's why I ran out of bits. You got it, Adam. Why didn't I think of that? Okay, so I can't really read that very well. So 39 is the version number. And then 65, line 65 is, so we're number of subpackets, one subpacket. So then it'll make a recursive call and get a version 1, and then one subpacket. And then another recursive call of 5. And then we're going to 57, so that's a length of 11 bits. And then 3 plus 3 is 6, plus 6 is... No, plus 5 is 6. Is 11. So a literal 15. And it should have stopped there, right? Oh, I didn't use the limit. Okay, I'm dumb. This, we never used this limit. In fact, it warned me that I never used this, right? Where do I use that? Oh, I never, wait a second. Why am I passing in the limit? I don't need to pass in a limit. I don't need that. I don't know what I was thinking. It's that while loop that's the problem. This is just pull packet. Again, pull packet and pull packet. We get this length out. It's the problem is I never set that. The length is probably not correct, right? It should be right. Let me debug this. Maybe I'm not getting the correct values out of the packet itself. To do that, I got to mark packet itself as debuggable. Or as, and it implements the debug trait, so we can print it out with a debug print statement. Let's run it again. So version 4, and then it's the... That means there's one subpacket. Version 1, one subpacket. Version 5, 11 bits. A literal 15, that's 11 bits long. And then why did it go into... Oh, no, it's returning back out. Okay, it returned all the way back out, and then it tried to pull again. Why did it do that? Is my while loop not right at the very outermost? Is this done not correct? Oh, no, we had some trailing bits. We had some trailing bits. So is it always just one outer packet then? Did they say that and I missed that? A single packet. Okay. I got that wrong then. The single packet means we don't have this at all. There's no loop. Which means I don't need to sum, it just is that. Which means I don't need that variable at all, I just turn that into a string. Okay. See, I go too fast and I get the wrong answer. Okay, so I'll just leave the debugging in and we'll just run 2021 cargo run 16.1. Just so I can get at least a score on this. 967. First try. You doubted. I know you doubted. I could see it in your eyes. You doubted. It is advent of realizing I can't read.com after. Yes, it is. Yep. Okay, on to part 2. Now that you have the structure of a transmission decoder, you can calculate the value of the expression it represents. Literal values represent a single number as described above. Remaining bits are more interesting. So they're telling us what these other ones are. So sum, the value is the sum of the values of their subpackets. If they only have a single subpacket, it's the value of that. 1 is product, 2 is minimum, 3 is maximum, 5 are greater than packets. So their value is 1 if the value of the first is greater than the second, otherwise 0. They always have exactly 2. 6 or less, they always have exactly 2. 7 or equal, they always have exactly 2. Using these rules, you can work out the value of the outermost packet in your bit transmission. Okay, so they give us some examples. Close. That is 3. How many more did they give me? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So literally taking their examples and putting them in as my unit test. This year, with only a few exceptions, it's been like this. Is that they are begging you. They're begging you, please, do test-driven development. Take the examples and make them your unit tests. That's a 1. And I'm all for that, you know? That's a 0, actually. The other one is a 0, too. And then there's a 1. And that's a 9 and a 7. And a 54. All right. Purist in the TDD would just say run it and expect that. It is not yet implemented. I don't know why I did it, but there it is. Okay, so I'm going to take part 1 and just change it a bit. All right. Actually, what I'm probably going to do is have to change a lot of it. Probably just, we're going to put more into packet, right? So let's just say we're envisioning we're going to have a value. And we'll have to add value to packet. All right, easy peasy. Except for we have to put a value here. Let's just put 0 there for now, right? Second step of TDD. Now it should say that I'm getting 0 for all those packets.
I have 6.
I should just remove those debugs because they're going to distract me.
6.
F3, see how I had to look at the keyboard to hit F3? I want a keyboard where I can hit F3 without looking. See, now I'm just going to obsessively think about the better keyboard I might have. What's this warning about? Done? Oh yeah, we never needed to call. We didn't need a done. See, Rust is helping me out. It's like, dude, you wrote that function. You don't need it. Yeah, so 0 is what I expected it to say, and that's what it did. So to get a value out, what do they say for packet ID 4? Okay, for packet ID 4, it is the number, so we'll just have let value equal that. And then the value of this is literal. The value of this depends on the type. No, not the length type. The value here depends on the packet ID. So let's turn this into a match then. Match packet ID, and then for 4, it's that. And then for packet ID type, it is a bunch of other things. And this is the common part, so we'll have a smaller match packet type ID in here. The possible values they gave us are 0, 1, 2, 3, and 5. So here's space for 0. I don't need this row column, by the way. 1, 2, 3, 5, and then that's panic. Arrgh, bad packet type ID. All right, 1, 2, 3, and 5. Packet type 0 is a sum. There are exactly 2, so that means I'm going to probably just collect these subpackets together. So why don't I just do that? Let subpackets equal, and then let me think about this. I think it would be easier to do let mute subpackets equal vec new, and then here we say subpackets dot push subpacket, and here as well. And then when we get down to here, it's subpackets 0 dot value plus subpackets 1 dot value. For this one, it's the product. So multiply. 2, it's the minimum of all of them. So that would be subpackets dot into iter dot map packet to packet dot value dot min dot unwrap. It needs to be at least 1. All right, and then 3 is max, right? And then 5 is greater than where there are 2 again. Oh wait, I did these ones wrong. It was 5, 6, and 7 that have 2. 0 and 1 can have many. So really, the logic of expecting 2 goes in 5. Oh, there's 6 and 7 too. Goes here, right? Where this is a greater than, and it's if it's greater than, it's 1 else 0, right? I'm going to allow that term. Rust makes that part sexy, not nearly so in Go. One of these days I'll have to try out Go. I'm in danger when I try something new out that I like it too much and I never go back to what I was doing before. So 6 is less than and 7 is equal? Alright. The formatter insists on doing that, that's okay. So yeah, for here it's more like this actually. It's this, but it's sum. And for this it needs to know a type. Don't ask me why, it just wants it. And you don't need to unwrap it. I wonder what sum returns if there's nothing. Is it just 0? Oh, it says there. An empty iterator returns the 0 value of the type. That's excellent. So I think on product, it's not so, right? It's probably going to want me to unwrap that. Now what does product do? Empty iterator returns the 1 value of the type. So that would be 1, I guess. The 1 value? The 1 value? There is the 1. The 1 value. So it's just 1. Okay, interesting. I didn't know you could take to find the 1 of a generic. What do they say if there's no packets? Okay, they don't say they can have 0 packets. So I guess we'll assume that there's at least 1. Well, let's try it out. Run the test. We pass. First try. We get a very huge number. We try the very huge number. And we pass! Yes! Woo! First try. Do the crab dance. Alright. That was fun. I like that. I like that I had set it up so that it wasn't too hard to add the interpretation of these other packet types right down here. And they really mapped well to either iteration or just comparison. It wasn't too bad. I had to do a little bit of finagling about, what was it? I had to get the packet, what was it? The value out, and I had to rearrange this. So it's a little bit different. Let me make sure I didn't break part 1 when I did that. Yeah, part 1 still works. Alright, how to do rank-wise. This one is one of the most work up front for part 1, unless you somehow write yourself into a corner. Yeah. Yeah there, A squared. Did I say hi already? I think you came in, yeah, you came in when I was super focused. Yeah, we just finished. Let's see how I did on the stats. Oh, that's the best I've done. Well, except for day 5, part 2. But check that out. Sub 1,000. If I keep that up, one more order of magnitude faster, and I'll be scoring points. Neato. I really feel good about this one. This was a little bit absurd that I did it that way. I think most people would have just taken this and done like a parse as hex, and then just shift left and compare it to a greater than or equal to 16, and then just do that 4 times to get the bits out. But I don't know. I felt the urge to just enumerate all the bits, and I felt that this is going to be pretty fast. Oh, that's the other thing. Yeah, how fast is this? Cargo bench that. Let's bench it. Let's bench that. So release build, and it's going to run it many times to sample as many as it can within, like, I think it's a default of 3 or 5 second time period. Yeah, so 202,000 iterations. That means we got pretty dang fast. 24, so like 25 microseconds to solve part 1. Part 2 is going to be a little slower, but I don't think that much slower, right? No, it's on the same order. It's on the same order. In fact, it's exactly the same. So 25 microsecond solution. That's not that bad. Not bad. Proper name for the 0 value and 1 value are the additive and multiplicative identities. But the standard docs try to avoid mathy terms. That's good for me, because I'm not a mathy person. I used to be in high school, but no more. I scrubbed away all that math stuff when I got out of college. All the interesting work is in the parsing. The rest is just addition. Yeah, I've done parsing before. That's maybe why I was able to do this so fast. I knew that I'm going to want to get it into a form where we can pull bits, and any number of bits, and not have to worry about boundaries or and make sure the bits are in the proper order. Once we had that, it's sort of trivial. We say, well, pull 3 here, pull 3 here, pull 4, pull 1. Probably the most complicated thing is that we have to interpret the types here, and sometimes we have to combine parts together, right? And this distinction between this is actually fairly typical of real world protocols and formats, is that you'll have length prefixed groups, and you'll have I don't know what to call it, like a quantity of subfields. This is actually more common to have length prefix, and this has the advantage in that if you don't know how to parse a subpacket, you just skip that number of bits, and then you can at least parse the outer structure to the end, right? You might not be able to parse the inner structure, but at least you can skip the number of bits. This has a problem where if you don't know the number of bits, you just you know the number of packets. It means you have to parse every bit of the subpackets to get out of that and parse the rest of the outer structure. But that otherwise is fairly typical. This being the more common, much more common. This is what you usually do if the subpackets have a fixed size, so you can compute the number of bits based off of the number of packets. But you know what? I wouldn't be surprised if day 17 is about using this to run some kind of machine. They're going to introduce types here like 8 and 9, then introduce registers and memory locations. Hey there, Karl Mark. How are you doing? How much do you guys want to bet? Tomorrow it's going to be the same machine, but we're going to have an 8 here, and it's going to be to load or store into memory. And then it's going to be int code stuff all over again. You fell behind admin code and now you're trying to catch up, but you got stuck. I suggest you just skip that day, because this year and last year, the days are independent. So if you get stuck on day 12, just try day 13. Don't get discouraged. Because I fell flat on my face on 3 different days, right? Here it took me like 2 to 3 hours, right? I could have just given up, and I still would have been able to do day 9, 10, 11, because these days had nothing to do with the dreaded day 7. I think I also screwed up on 10 was not so good either. I think it was day 8 I also messed up, and day 3. These ones have really large times also because I didn't start on time. But yeah, just take the next day. Like yesterday was about pathfinding. This day is about parsing. So they're completely different kinds of problems, and so you'll end up having fun on those days where you're in tune with the problem, and on those days where you get frustrated, just skip them. If you're not learning, you're not having fun, just skip it. Skip 14 days, yes. Go straight to day 16, and then if later maybe you learn something, you have more experience, you have some eureka moment, some aha moment, go back and resume those previous days. Just annoyed because you solved the testing data. Yeah, that's really annoying. I've had that happen where the test passes but the real thing doesn't. They've been pretty good at making the examples fit the real input, but there have been a few days where they didn't, and that can be really frustrating. What you can do there maybe is get the input and output from other people and try those. You see the one link yesterday about the stuff that someone posted in Discord? What was that? I think I did, but I can't remember. I have to look at the Discord again. What was it? Was it the solving it with folders? That one? Is that what we're talking about? Or that's am I forgetting the wrong? I'm thinking the wrong forum. In the AOC channel, the spoilered link. Okay, let me look. Oh, that the Rust doc page for binary heap contains the Dijkstra's implementation, so I could have just gone there directly and seen it. Oh, yeah. So I could have just copy-pasted this. That's Dijkstra's algorithm. I can see it, right? This one, that's the core of it. I could have just taken that.
That hurts you.
Yeah, well, you know, my problem yesterday wasn't that I was lacking in implementation. It was just that I was too tired. The directed graph 2, you think? Yeah. You can use Dijkstra's for directed graph. It's not limited to grids. As long as you have a way to find your neighbors with costs, and the costs can be different. If there are different ways to get to the same spot, you can actually have different costs. Like here, 1 to 3 and 2 to 3 have different costs. The algorithm doesn't care whether it's a graph style or a grid. It works. It's a pretty cool algorithm. Yeah, this one says general. Yeah. So yeah, I could have used this, but that's okay. It's pretty ironic though, that if I had, because I ended up using binary heap yesterday, right? And if I had been reading through the docs and saw that, I would be like, what? I could just copy this. Yeah, I ended up using binary heap for my Frontier. What did they use? Is that why they're using the heap for their Frontier? They call it heap, but yeah, that's the Frontier, right? It's literally the same line of code here. While let something equal heap pop, while let something equal Frontier pop. If position is goal, return. If position is goal, break. Well, I have a break because we had to do one more thing, but yeah. And then we have the better way. Oh, that's an optimization, right? We don't need to do that. It would figure it out by this always being false, right? So I could have added that to like escape early, but instead I go into the same loop that they have for each. So each edge is like each neighbor, right? Figure out the state, and that's what I do here. And then here's the core condition here. And push it onto the Frontier and remember the cost. That's what I do right here. Yeah, it's basically the same. Goal not reachable, none. We unwrap. This is the Wild West. We either get the answer or we panic. This is playing it's too safe, I think. All right, you can tell I had fun because I'm like very giddy. Okay, so I enjoyed that let's pass on the positive vibes to someone else who's working on this. We did a good solid hour there. Let's find someone who's struggling and encourage them to keep going. Okay, so Anthony Wright's Code is doing it still, so we could raid him. Assuming he's still working on the same problem, that would be cool. I hope I don't get an ad. Please, no ad, please. Oh, I got an ad. Shoot. Well, I'll set it up. We're going to raid Anthony Wright's Code. He usually is programming in Python, or he's doing something more esoteric, like trying to solve advent of code in SQL, which is crazy and clever, and I wouldn't be able to do that. So, yep, we're going to check out what he's doing, give him some encouragement if he hasn't already solved it. All right, so see you next time. Thanks for watching. Bye. Bye-bye. Cleaning up his implementation. Okay, we can still see what he did. Bye.